Section 3.5 is titled Solving Inequalities with Variables on Both Sides. You don't have to write this down. This is very similar to yesterday. This is just how to solve inequalities with variables on both sides. So again, we're still solving the inequality like you would any equation. You want to clear fractions, get the variable on the same side, move the constant to the other side, and then divide by the coefficient. The only thing you have to remember with inequalities, the biggest difference, is that when multiplying or dividing by a negative, we have to flip the inequality symbol. And then we always want to end up with our variable on the left. It helps with shading. So let's look at some examples. We're just solving the inequalities here for the notes. We don't need to graph these today. So first, we see that we don't have any fractions to clear up and we don't have any terms to combine on either side. So now we need to get the variable on the same side. I like to move the smaller number over to the larger number. That way I'm not dealing with a negative. So we end up with 2m minus 3 is less than 6. And we add 3 to both sides. 2m is less than 9. Divide both sides by 2. M is less than 9 over 2. It is an improper fraction. We don't need to change it to a mixed number because it is in simplest form. Number 2, we have 5 times the quantity of 3 minus t minus 7 minus t. So first we want to distribute. We distribute the 5 through. Remember, we're multiplying it by both pieces. Watch that negative sign there. So we have 15 minus 5t is less than 7 minus t. So we have negative 5t and a negative 1t. This is actually the larger number. So I'm going to add 5t over to the right. That gives me 15 less than 7 plus negative 1 plus 5 is a positive 4t. Now we're going to subtract 7 over to the left, and we get 8 is less than 4t. Divide both sides by 4, and we have 2 is less than t. But remember, we always want to write the variable on the left-hand side, so when we rewrite it, we say t is greater than 2. Number 3, we have 1/2 a plus 5 is greater than or equal to a minus 1. I'm going to multiply everything by 2. I want to get rid of that fraction. Remember, every single term needs multiplied on both sides of the inequality. So here we get 1a, or a, plus 10 greater than or equal to 2a minus 2. I'm going to subtract the 1a over to the right-hand side. That leaves me with 10 greater than or equal to a minus 2. Then I'm going to add 2 back over to the left. We have 12 is greater than or equal to a. And again, we want to write our variable on the left-hand side. So we say a is less than or equal to 12. Number 4, we have 2 sets of parentheses where we need to distribute, one on the left and one on the right. So that gives us 12y minus 3 is greater than or equal to 8 minus 2y. Make sure you have your signs correct. 12y and a negative 2y, so I'm going to add the 2y over to the left. That gives me 14y minus 3 greater than or equal to 8. Now I'm going to add 3 back over to the right. 14y greater than or equal to 11. We divide both sides by 14, and we get that y is greater than or equal to 11 over 14. Number 5, 43 plus 7n less than or equal to 4 times 3n plus 2. So again, we need to distribute on the right first. 43 plus 7n less than or equal to 12n plus 8. Don't forget to distribute all the way through. I'm going to subtract the 7n over to the right. So that's 43 less than or equal to 12 minus 7, 5n plus 8. Now we're going to subtract 8. 35 less than or equal to 5n. Divide both sides by 5. We get 7 is less than or equal to n. And we want the variable on the left. So n is greater than or equal to 7. The next two examples are specific examples. We did ones very similar to this when we were solving equations, and I just want to refresh your memory. So first we need to distribute on both sides. This is negative 5k plus 5. Remember, it's a negative 5 times a negative 1 greater than or equal to 10 minus 5k. And some of you may recognize this right away. When you have the same variable with the same sign on each side, they're going to end up eliminating. If I add 5k over to the other side, it eliminates here and leaves me with 5. It eliminates here and leaves me with 10. But what you have to be careful with here is now we're not looking for two numbers that are equal. Now we're just looking for a true statement. So the question is 5 greater than or equal to 10? That is not true. This is similar to when we did it with equations, and you would be left with something like 2 equals 7. That's also not true. So since 5 is not greater than or equal to 10, we have no solution. Let's look at another example. Let's distribute first. So we have 30 plus 3z less than or equal to 3z plus 36. So if we subtract 3z to the other side, again, we're going to have our variables eliminate. So we're left with 30 less than or equal to 36. Now read that statement again. 30 less than or equal to 36. Is 30 less than or equal to 36? Yes, this is true. 30 is less than or equal to 36. So when it's true, our answer is all real solutions. Or all real numbers, I think is what I said. So it's a little different. It's not checking that the numbers are equal. We're checking that the statement is true. 30 is less than or equal to 36, so we do say all real numbers. In class, we'll work on worksheet 3.5, and we will be taking a quiz over the first 5 sections.